Satellite collisions in low Earth orbit could set off a dangerous chain reaction of debris known as the Kessler syndrome, making space unusable for decades. Join me, Emma Robinson, one of the co-hosts of Wharton Tech Talks, in talking with Araz Feyzi, co-founder and CTO of Kahan Space, a company trying to prevent this from happening. We also discussed the complex regulatory challenge that is space. This is the next installment in our space series. Listen to our other episodes or give us a follow to stay tuned for more. Hi, Araz. Thank you so much for joining us today. Where are you dialing in from?
Thank you for having me, Emma. I'm dialing in from Northern Virginia.
It's not too far. Definitely different than the normal Silicon Valley answer we get. Could you describe Kayhan and your role for our listeners in layman's terms, just to get started?
I'm the co-founder and chief technology officer here at Kahan Space. At Kayhan, we are focusing on solving a major problem for space industry today, which is space traffic coordination. There's been a fascinating growth in space operations. We're expected to launch 10 times more satellites in the next decade alone compared to what we have launched so far since the first satellite. So we have more launches, more satellites, smaller companies that launch satellites, and increased population of operational satellites plus debris in low Earth orbit. What that means is that we have all these satellite operators flying in vicinity of each other. And a lot of times they come too close to each other, but there's no rules or regulations or a procedure or process in place where satellite operators can deconflict their operations around each other. Our Pathfinder product is the first, and as far as we know, the only commercially available space traffic coordination platform for satellite operators. Automate their coordination and deconfliction in space amongst each other.
So what does that exactly mean? Is a satellite trying to get to a certain orbit, or is there a piece of debris coming at the satellites that you have to help them dodge, or what does that look like tactfully?
All of them. When we started, one of the biggest challenges for satellite operators that they had, annoying problem, I wouldn't say the biggest challenge, one of the annoying problems for satellite operators was dodging orbital debris. So you get these notifications called CDMs, or conjunction data messages from US Space Command, that, hey, you're in 18 hours or in 2 days, you're going to come this close to a particular piece of debris, for example. And then you have to, first of all, decide whether or not you want to take an action. And if you decide that you need to take an action, which means burn your thrusters, move and get out of the way, or increase your distance or probably have collision with that piece of debris. But that is a manual process in general. So with our Pathfinder 1.0, we solved that problem. We automated the collision avoidance processes for satellite operators. So in that case, it was one operational satellite versus a debris. It could very well be two operational satellites, but we were solving one side of the problem. We were assuming that the other party was not going to planning on changing their direction. But today, historically, that type of risk, meaning conjunction is a technical term for close approach or potential collision event, so I'm going to use that term. So the majority of the conjunctions have historically been between when one side is an operational satellite, the other side generally is a defunct satellite or a piece of debris. So that's historically that has been the trend. Well, now that's changing quite rapidly. Now we have a lot of cases where two operational satellites are in a collision course. And that's because there are these more preferred and popular orbits in low Earth orbit where new constellations are going to. Think of it as 400 to 600 kilometers above our surface, and Sun-Sync orbit, which is a particular polar orbit that is very popular for Earth observation satellites. So you have space is big, but you have these highways that are very popular, so everybody wants to go there. And then when these operators don't talk to each other, which there are no globally accepted rules and regulations or best practices of coordination space, the state of the art has been that you have to pick up the phone and call the other party or email them if you knew who they were, or if you didn't, you have to figure out who it is, who's going to respond to the email. And sometimes you have very last minute kind of notices. So 3.0, we're solving that problem. So we are allowing satellite operators to set up rules of engagement among themselves ahead of time. So when and if something happens, they already have an agreement in place where they know who's going to take what action. Now, the other party can always, or either one of the parties can always deviate from that, propose a counter proposal or what have you, but we are solving that part of the problem. So think of it as air traffic control, but for space. Now, the biggest difference is that there is sovereign control over airspace in most cases, but space doesn't belong to anyone. And because there are no rules and regulations, it is really on a case-by-case basis how operators deal with things.
I want to revisit the rules and regulations component a little bit later on, but my immediate follow-up to that is, space is fairly vast. It can't be as busy for air traffic controllers as, say, JFK Airport. How often do these conjunction events actually happen, or how often is there a risk of them happening?
That's a great question. So let me give you a real example. We have a customer that has around 100 or so satellites. On average, they get somewhere between 60 to 80,000 notifications every single month. Now, 60 to 80,000 for a constellation of 100 satellites that's flying in low Earth orbit. And now, granted, a lot of those can be ignored because either your risk of collision is very low or your what's called a miss distance is very high, meaning you can ignore them. But you can imagine if you're operating such a constellation, you either have to build a solution in-house to filter, basically separate noise from signal and only surface the important things that you need to care about, or you have to basically throw humans at it. Most operators just have a shared mailbox that a bunch of operators watch, and people take action when they see high risk events. So our solution automates all of that. We go through all of that. We collect additional data. So think of it as when there's a high risk event that you need to know of, that's the only time that you get a notification in Slack or Microsoft Teams or SMS or email that, hey, there's this case that you need to worry about. And this is our recommendation. This is what we think you should do. And you have these 4 or 5 choices that you can choose from to proceed.
How exactly have you automated this process? Where do you collect your data from? Is it all just based on algorithms and trying to predict the movement of satellites and debris?
Historically, U.S. government, in particular space surveillance network that's operated by Space Force Net, has developed the largest, what's called a catalog of space objects. So they track roughly between 30 to 40,000 objects in Earth orbit. Anything larger than a softball in low Earth orbit, they can track it pretty precisely. That includes operational satellites. There are other companies, commercial organizations, and a couple other governments that have systems, but the U.S. Space Surveillance Network, or SSN, is the most comprehensive and more accurate one. We have an agreement with U.S. Space Command and U.S. Space Force that gives us access to this controlled but unclassified database of space objects. We get that once a day. It's updated on a daily basis. So that's our main source of data. This data set is created with radars, telescopes, and some in situ assets that U.S. Space Force operates in space. As you can imagine, being a couple hundred kilometers away, having radars, your confidence level is not always high. When you're tracking smaller objects or certain types of objects, you get high uncertainty. So you can think of it as a bubble, right? You say, I think this piece of debris is somewhere in this bubble. And this bubble can be small or big. The bigger the bubble is, the higher uncertainty you have. What we do is for operational satellites, and particularly our customers, we get access to the GPS that they have on board their satellite and use that GPS data, if they allow us, to more precisely predict their trajectory. And then we use that when the quality of that data is superior to the quality of the data we get from Space Force. There are some companies that publicly publish their precise trajectories, such as SpaceX, and a couple of companies that do it. So Starlink, I think they update it 3 times a day, if I'm not mistaken. It might be once a day. But they publish it so everybody can get access to it. So what we do is that we find the most precise source of data we have access to, and we use that to kind of recalculate the dynamics of the conjunction or potential collision. A lot of times, that bubble that I talked about, that shrinks. So which means you actually have a much better understanding of the event. So imagine 2 giant bubbles intersecting. The intersection is pretty big, right? So you're like, oh, there's a risk of collision. That's how I explain. As a non-aerospace engineer, that's how I explain to other non-aerospace engineers. But when you have better data, those bubbles can shrink in size, and they may not even overlap. All of a sudden, when you thought that there was a 2 in 10,000 chance that you're going to hit another piece of debris on another satellite, with new data, you may realize that it's actually 3 or 4 orders of magnitude less likely. And you can avoid maneuvers. What you want to do, as much as you want to perform maneuvers to stay safe, but it's more important to know that a lot of times performing maneuvers are riskier and more costly. So you're trying to eliminate the unnecessary maneuvers just to increase the life of your satellite because you're using fuel to perform maneuvers, and also things can go wrong when you perform maneuver.
Mm-hmm. And also collisions happen very rarely, if at all, honestly, in space. But unlike here on the ground where we can clean up afterwards, there's a cascading effect to any collisions with the debris. Is that right?
Yes. So Kessler predicted this a while ago. So Kessler syndrome, it's a chain reaction of basically cascading events. So you have two objects hitting each other at 17,500 kilometers an hour. One of them is going at that speed. If it's a head-on, it's double that. At those speeds, a collision can result in thousands of pieces of debris. First of all, when you create pieces of debris, the larger one we can track, the smaller ones we can't track. If it's less than 10 centimeters in diameter, we can't reliably track those. You have a collision happening, then the debris from that gets into other orbital shells, and then you could have cascading collisions, and each collision will create more debris, and it can create a chain reaction. Again, it's known as Kessler syndrome. That can render an entire orbital regime for decades. If something like that happened in low Earth orbit, it's important to remember that it doesn't affect low Earth orbit. If you want to get out of Earth and go beyond Earth, you have to go through low Earth orbit. So that could potentially reduce our access to higher orbits and to cislunar environment and to interplanet and anything affect interplanetary missions as well. So it's very important for us to avoid that. Now, some people believe that that's happening right now at small scale. So if pieces of debris that hit each other create smaller pieces of debris, it's not really, those breakups are not really well tracked, especially if it's happening to smaller pieces of debris. But hopefully the big one won't happen because that can actually reduce our ability to launch through this cloud of debris to other orbital regimes.
Mm-hmm. So you're bringing not only, to summarize the value proposition of Kayhan, it's not only like life extension of your clients' satellites, ensuring they conserve fuel, but there's also just a wealth of positive externalities for the entire future of the space system, the space industry.
Space sustainability issue. Earth orbit is an infrastructure. It's a resource. And if you're not careful, if you pollute it, it's going to reduce everybody's access to it. So it's a very critical space sustainability issue that we're addressing here.
Mm-hmm. So you must be working with, as you mentioned, you're working with a Space Force. There must be some sort of policy or regulation in place to try to mitigate these conjunction events, mitigate the risk of increasing debris on orbit. How are you working with regulators? How do you see that space facilitating your business?
One thing that we say is that technology alone is not going to be able to solve this problem. You have to have broader level conversations, both on the policy and regulation side. Now, the problem with this issue is that when you look at it from an international perspective, you have a lot of conflicting interests and egos in play. So far as of right now, we do not have a globally accepted set of rules of the road or best practices. However, in absence of that, industry has gotten together. There's something called Space Safety Coalition. It's a group. They've come together and they've proposed some sort of best practice. It's called SSC, Best Practices of Coordination in Space. We have endorsed it as a company. I think somewhere between 20 to 30 companies have endorsed it. Actually, in our product in Pathfinder, you can choose to adopt those guidelines. You can say, my company's policy is to follow those, and it will automatically apply to every single conjunction event that you have. So we work with other operators and other partners to push these conversations forward. There are conversations happening in the government levels, generally referred to as track one conversations, where governments talk to each other. There are tier two conversations, which is commercial companies from different countries are getting together and having conversations. We're also part of those as well. So we work with our lawmakers in the US to raise awareness, to make sure they understand the problem. We work with domestic and international companies to form rules and regulations or best practices that we think are right, because we believe they can be used as the baseline for future regulations. And we also work with other stakeholders, such as insurers, such as financiers, because everybody has a stake in this, right? If somebody loses an asset, it's not just that company that launched it is going to be affected by it. There's a chain reaction of effect that can ripple through industry. So we're trying to bring everybody, we're playing our role in bringing everybody to sit down and talk about it and try to come to a solution.
Mm-hmm. You're so reliant on data and sourcing data from others. You spend a lot of time trying to source data from non-US companies, or is the US data supply sufficient?
Again, US Space Force has the best and most precise catalog out there. And US companies are leading the way in collecting data in innovative ways. So mostly we work with US companies, but there are a couple of international companies that we also work closely with to procure data.
Yeah, no, the US is pretty dominant in that sphere, but it's still so difficult to get other countries to align on similar goals. Is there any dream or any big barrier that you think we can overcome in the near term to facilitate a safer future in space?
Well, if I had a wish list, I would go with a couple items. One, let's come up with some standards, data standards that we can all use. We shouldn't have 10 different standards on a particular concept. So we should be able to get together and at least set up some standards for data transfer. So that's one thing. The second thing is that I hope that we can all get together and say, we're going to share with each other some basic information that it's not that sensitive. Two of the most important pieces of those information are one, what I think, based on all the sensors I have on board and everything, this is my precise trajectory that I think I'm going to be on for the next couple of days. Plus, if there are any maneuvers that are planned, to share that with others, or we'll call it intention. It's a huge problem. So let me give you an example. So let's say you have two operators that are not communicating with each other or with anybody else. One of them wants to perform a maneuver, checks it with Kayhan Pathfinder, and Pathfinder goes, if you perform this maneuver, you won't hit anything. And the other party also wants to perform a maneuver. They don't tell anybody, and then they perform a maneuver. Now, ground trackers see things after the fact. They say, oh, I think this object is going to be here when I see it, but oh, it's not here, it's over there, so they must have performed a maneuver. Let me figure out what they did. So all of a sudden the uncertainty grows and lose confidence in data. There could be cases where people perform or operators perform maneuvers, don't share it with each other, and it puts them on a conjunction course or collision course. That's so last minute to detect. Think of it as a system with a delayed feedback. So you can actually throw it in chaos very easily. One of the things that we advocate pretty heavily is for operators to publicly share their trajectories and also their intentions. Obviously, there are some national security missions that certain governments won't feel comfortable sharing. But if you're in Earth observation constellation and just collecting data, I don't think there's much sensitivity on that. We need to kind of reduce the sensitivity that we feel like some sort of this information has and share it broadly, because it's very critical for safety of every single operator.
Yeah, it sounds like something that is only going to work if everyone buys into it. But from a business perspective, I mean, data is becoming increasingly valuable. Have you found it easy to get people to give away their data for free, or is there a future where there's a paid model or you purchase it?
I think GPS-based satellite data, I think that's something that it's very well understood that as long as if you're using that for safety of flight, I think folks are generally comfortable sharing that for free, because it not only ensures others' safety, but also ensures your safety. When it comes to commercial data providers, I personally believe that I yet to see a commercial operator that they've proven that they have better data than US government. That could change very well. That could change in the future. What I think the opportunity is for commercial data providers is, and what I mean by that is companies that have radars or telescopes or other sensors that track assets in space. We need to remember that Space Surveillance Network is a national security system. It's just like GPS. GPS was developed for national security, and then it was opened up publicly. It's kind of the same thing. It was designed to detect and track ICBMs, and by product of that, it tracks objects in space. Now, the core mission is that, not to tell a satellite operator, a commercial company, a satellite operator where their assets are, what their risks are. The Department of Commerce has actually taken over this function in the US from DoD, and they're going to procure some commercial data to enable that, but they will continue to use US government data as well. Now, these satellite operators, now all of that to say is that US government, I don't think it's US government's job to actually change their schedule on a daily basis to, for example, task their sensors to track data, to collect data on a particular commercial asset because they ask for it, right? It's taxpayers' dollars it has to go to what the mission is for. Now, there are opportunities for commercial data providers to fill that gap. So one example I'll give you is that imagine I Kayhan as a customer, and our customer has a satellite that, there's this other piece of debris that causes a lot of trouble for their constellation. It consistently comes in and it's all well tracked. I see a day where we can work with other data providers and task them to get more precise data, to bring in and recalculate all of those conjunction events, which potentially could reduce the number of maneuvers this operator performs. So it's a kind of a win-win situation. So I think there's a place in the market for commercial data providers, but I don't think we will be, as a company, at least today, it's not in our business model to purchase data to provide to our customers. We will more than likely will play a marketplace role, if you will, when it comes to space data.
No, that makes a lot of sense. One thing we've heard in this space series often is that the space industry is a fairly cooperative environment where everybody wants each other to succeed and understand that there's just a huge gap when it comes to regulation and governance in space. And it sounds to me that that's really boosted people's desire to cooperate. Would you agree?
I do agree. I think conversation has changed quite significantly over the past year, year and a half. I think one of the biggest challenges that we all face today is that there's almost no coordination between Chinese operators and other operators. That's a problem that we focused on. We are part of some of the track 2 conversations with our counterparts in China. The US government has a track 1 conversation with Chinese government. I think both parties agree that this needs to happen. Both sides agree. And I think we're making progress toward that.
I mean, that's not to say there's no cooperation between US and China on these issues. I think we've all, correct me if I'm wrong, but have agreed on not testing anti-sat weapons that would just, I mean, they already have in the past, but no more. So there's still a little bit of a cooperation.
Obviously. So I think we've come a long way. Sometimes we forget US has done more ASAT tests than any other country. But we stopped a long time ago. So what I'm trying to say is that, and my comment was just when it comes to coordination between satellite operators to deconflict conjunctions. In that particular area, there's very little interaction happening. I know of one case where US operator coordinates with Chinese side when it comes to Chinese space station because there's human life involved. So in that particular case, I know there are communications happening, but we need to make sure that that expands to other areas of space operation.
Yeah, it's a special challenge with the advent of deglobalization and wanting to keep everything, especially data, housed within borders and not shared. But switch gears a little bit. You do not have a space background, am I correct?
That is correct.
For our listeners who are MBAs, we may have a few people listening to this that are interested in space already, but for those that are now maybe catching a space bug or want to learn more, how did you get involved in this sector and what advice do you have to people who also might be interested in it?
As most kids are, I was very interested in space when I was growing up, but I like computers more. So that's the path I took, and my entire life was consumed by automation and computers. My co-founder, however, who's my friend from high school, went to college together, we're roommates. He has a PhD in aerospace engineering, has a postdoc, has done a bunch of NASA JPL missions, commercial missions. And when we were talking about potentially starting this company, he used to, obviously we're very close friends, we used to talk all the time. He kept talking to me about all the challenges the space industry is facing and how he thinks we won't be able to grow as fast if we don't resolve these issues. And he eventually convinced me that the opportunity is big enough for me to jump in. So yeah, it's been 4 years of learning. In fact, last week I had a great day because I sat next to a very famous astronaut on a panel and the two of us spoke, represented space industry at an air traffic control conference. So when you get into space, there are the very difficult corners of the industry where you really need to go get an advanced degree to learn. But space industry is not just rockets. It's not just rocket engine. It's like any other industry. You need software, you need processes. I encourage everyone to come take a look at it as an industry that is growing really rapidly and it's really fun. My previous company was in cybersecurity. I can tell you that I get a lot more attention at parties when I talk about what I do. So I don't think I top space.
That's certainly an added benefit. At the very least, you sound cool. Besides that, it doesn't matter.
Actually, sorry to cut you off, but in fact, that makes hiring very easy too. So not very easy, but it makes it easier to find the right talent, to convince the right talent to come work for you for less money. That's another benefit of it's not just fun at parties, it's fun when it comes to recruiting as well.
Yeah, I mean, part of the reason I'm doing this series is just because I think space is so cool. So hopefully other people do as well. What skills do you think you brought to the table coming from a non-space background that perhaps your co-founder was lacking?
It's not necessarily my co-founder was lacking. What I noticed early on was that you have a lot of smart people, literally rocket scientists, who also think they're the smartest people on Earth, which is probably correct. So they think they can do everything, including writing software. So when you come to space industry, you realize that there's a lot of products and engineers built for engineers. And also some of the attitude from old space kind of was transferred over to new space. Back in the day, if you wanted to launch a mission that was going to cost us $1 billion, you would throw like 50 PhDs at it and it would take 5 years to do. But now you have companies that they've raised a couple $1 million, they have a couple of satellites flying. So the mentality was not going to work. So when we started this company, a kind of one of my conditions was that we're going to bring the best technology out there into this industry. Aerospace industry or space industry deserves better. So one example I'll give you is that this year, our Pathfinder product was finalist in 3 different design categories with Fast Company. And I think it's a great achievement. That's what we're bringing to every aspect of our product. Best cloud technology, the best product development processes designed to be top notch. So we're bringing the best staff from every industry, the best technology out there into space industry. So majority of our folks on our team don't have a space background. I mean, we do have 4 or 5 PhDs and a couple other folks with masters in it, but most of the team are just to bring talent from different industries.
Yeah, I mean, one core difference I think with Kayhan is that a lot of the other companies we've talked to in this series have more of a actual launch components, or they're actually operating something in space. And so you're a more unique example, and not unique to the space industry, unique to our series, where it's just software and it's this transferable skill from all sorts of other industries. So that's worth noting to the listeners. But could you share just a memorable experience from the past few years that it's had a significant impact on you as a founder or an entrepreneur?
Well, this year was an incredibly difficult year to raise a round of funding, but we did it. And I think it's one of the hardest things I've done in my life. So we closed a round of funding in September. And I know it's not necessarily a space-related experience, but I joke about it. I joke that I don't think I've heard the number of rejections I heard this year is more than what I had received prior to that in my life combined. But I think the larger message, I guess, is that nothing is easy. But once you have a mission and you're driven by the mission, I think you won't, and if you believe in your mission, you won't stop until you get there. And we started this company 4 years ago in an industry where trust is a huge, huge factor. So unless somebody knows your name, knows your background, knows your company's logo, they won't trust their knowing their assets with your software. It was an uphill battle, but like any other industry that is ripe for disruption, I think there are many opportunities in industry today that some of the listeners can start poking and come and disrupt the industry, because the next frontier is space. There's not much left for us to explore here. So we're explorers deep down. If you don't explore, we start hurting each other. So this industry is actually at risk of slowing down when it comes to progress if you don't solve a lot of issues that the industry is dealing with. And it's not just better rockets, better engines. It is policy, it is optimization, it is procedures, it is software. I encourage everybody to take a serious look at the space industry.
Yeah, I mean, space, most of the capabilities we can utilize space for, most of the products we can deliver using space have yet to even be thought of. And so it's one of the most, in my opinion, exciting industries. My final question on that note, but are there any other parts of space, any other subsectors within space that you're particularly excited about?
Oh, there's so many, but one of the areas that I think there's still a lot of opportunity to make improvements is manufacturing. We've come a long way. It used to take years to develop a satellite, build it, launch it. We've cut that down quite significantly, but I think there are a lot of best practices that can come from other industries to space industry to help us reduce the cost of developing assets and also increase the efficiency at which we develop these products. It shouldn't take us a year and a half to build a satellite and then another 6 months to find the slot on a launch mission to launch it. We should cut that down, and there's a lot of opportunity there.
Yeah, no, one of our earlier conversations was with Starfish Space, and talking to them about how long it took to get the satellite bus, etc., was eye-opening. But yeah, thank you. I've personally heard about Kayhan a few years ago, believe it or not, and so it's been a pleasure talking to you. Thanks for coming on the podcast.
No, thank you for having me.